Okay, well, welcome everyone to our annual spring online refresher training for returning volunteers. So thanks for coming back to WAVE this year. And I hope you're enjoying this warm week. I'm only slightly worried about all of the spring plants coming up, but hopefully they've managed to be hardy all winter and they'll come through. My name's Katie Bradford. I'm the program manager for Water Action Volunteers. And I work out of Madison, Wisconsin, but of course we support volunteers like you all over the state. And Emily, do you want to introduce yourself really quick?
Hi, everyone. I'm Emily Heald. I'm the Rivers Educator here at the Division of Extension. I work closely with Katie in the WAVE program.
Thanks. So we're both going to be sharing some program updates and reminders with you today, just so you feel all set to go for the monitoring season. Let me get my slides going here. So just so you can see who the team is, most of you haven't seen our WAVE student assistant, Sean Bertolat. He's a UW-Madison senior graduating in just a few weeks. We're sad to see him go, but he's the one who helps pack a lot of the chemicals and kits to supply volunteers, as well as helping with a variety of other projects. And of course, you've met the other two of us. So today I wanted to give you a quick summary of WAVE from last year, just so you have a sense for what's happening all over the state, and provide you with some updates on 2023, a few new resources we have, any program changes that you might notice. Then I'm going to walk through with photos the 5 baseline stream monitoring methods that you use out in the stream every day, just to make sure that we're all following the protocols to collect high quality data. Emily is going to share some of that as well, and also talk about aquatic invasive species to look out for and opportunities to get involved in that effort. And then one more final event to look out for coming up. So let's start by giving you a quick summary of what was happening across the state with stream monitoring, volunteer stream monitoring. And just to remind you that we have 3 different kind of roles that we imagine people being involved with WAVE in. So I believe all of you will have experience, or at least maybe if we have anyone who got trained in fall and is starting this spring, doing baseline monitoring. So doing temperature, transparency, dissolved oxygen, stream flow, and biotic index every month. That's what we're covering today. Then we have our special projects monitoring volunteers. So after doing a year of monitoring, we have opportunities for volunteers to help collect nutrient samples, such as testing for pollutants like total phosphorus in our waters, nitrogen, total suspended solids, so like the sediments that are in our waters. Deploying thermistors, which measure continuous temperature in our streams and give us kind of that long-term trend of if our streams are warming up, staying cool, what that looks like. Getting involved in aquatic invasive species monitoring. These are some of the special projects volunteers can do once they've been doing baseline monitoring. And then, of course, we have our wonderful local WAVE coordinators who may be county staff, watershed, nonprofit staff, very committed volunteers like yourselves who help coordinate and support WAVE volunteers throughout the season. And we really couldn't do this without all of them. So here's some photos showing volunteers at trainings last year. We had 174 new baseline volunteers trained last year, and our WAVE coordinators trained the most of them. 393 people across the state submitted stream data to SWIMS. So thank you if you were one of those folks. We also have tons of volunteers who help do stream monitoring, but may not show up in SWIMS. So we recognize that. And we had stream monitoring in 55 of Wisconsin's 72 counties last year. So we're always trying to get monitoring represented in every county. And that's a lot of what I do is reaching out to new partners to make that happen. So here's a map of our 2022 stream monitoring sites. We had 446 baseline monitoring sites last year, 112 nutrient monitoring sites, and 50 thermistor or temperature logger sites. And if you'd like to check out all of that data, you can do so on our website on the WAV data dashboard, which I've been promoting in various places. And I just want to show you how to view that data really quick. So if you're on the homepage of wateractionvolunteers.org, at the top, we have a data tab, and you'll see here, let me make this bigger actually, so make sure we can show it. We have a data tab here and a drop down for our stream monitoring data dashboard. You can also click to get to it just by clicking on data and going to our stream monitoring data dashboard button here. And since there's so much data, sometimes it can take a few moments to load. Once it's loaded, you'll see the map of all of our WAV volunteer stream monitoring sites across the state, color coded. The green dots, if you can see the color here, is baseline stream monitoring, or you can hover to see what type of monitoring it is. The orange dots have at least nutrient monitoring, but they may also have other types of monitoring. And the purple dots have at least thermistor monitoring, but may have other types of monitoring as well. So you can find your own site. You can select multiple years of data. You can view charts of your data as well, whether it's baseline, nutrient, or thermistor data. And I'll just note too, I don't want to spend too much time on this, but if you go all the way to the bottom of the page, you can download as an Excel file all the data you have collected. So that's a great way to explore data from 2022. We upload the data from SWIMS to this dashboard twice a year, once after the December 1st data submission deadline, and once in summer after the busy spring training season. So if you submitted your data a little late, it might not show up right now, but we will pull the data from SWIMS again after the spring. So you'll have another chance to see it show up. Okay. So let me share just a few program updates in 2023. And again, if you have any questions, drop them in the chat and we can answer them as we go. So I just want to remind everyone what we ask of WAV baseline volunteers. So number one is safety first. Don't enter the stream if it looks or feels unsafe. We don't want you monitoring after a big storm event when the stream is raging. Definitely wait a few days before you go out there. And keep other things in mind, like, slippery surfaces, the weather. Don't go out if there's a thunderstorm. And we really encourage everyone to monitor with a teammate so you're not out there alone. We ask volunteers to monitor their stream site once a month from May to October. Generally, we suggest that you choose a day and go out that same day every month. Like, I'm going to start going out Saturday, May 13th, and I'm going to go out every 13th of the month through October. After you go out, we encourage you to submit your data to SWIMS right away so that you don't lose that data or forget to submit the data to SWIMS. We also ask that you take care of your equipment, make sure you check for expired chemicals. And if you need anything, the first person you go to is your WAV coordinator. And if you don't have a WAV coordinator or they're unable to assist you for some reason, then you can reach out to WAV program staff. We also ask baseline volunteers to report any suspected aquatic invasive species. So Emily will talk about that later. And if you do have a local WAV coordinator, definitely stay in touch with them about how things are going or if you have any questions. So just to note, for those of you who may not currently be working with a WAV coordinator, or maybe you know someone in another county who's interested in getting involved, we work very closely with our WAV coordinator partners. We have 44 currently who are active across Wisconsin. 56 of the 72 counties have a WAV coordinator active in them who are supporting volunteers in that county, at least in some watershed in that county, if not the entire county. And Emily and I are onboarding 5 new organizations this year to WAV. So we have new coordinators coming to Kenosha County, Sheboygan, Door County, Lincoln County, and Marathon County. So if you know anyone in those areas who wants to get involved, we'll have new people there. And we do have a searchable list by county of WAVE coordinators on our website if you aren't connected to one currently and you want to see if there's one in your area. We created this little resource, which someone asked for this year. We thought it was a great idea. It's just a 1-pager baseline stream monitoring calendar that volunteers can use to keep track of their monitoring each month, and just reminders as to kind of what the expectations or asks are. This is particularly useful, I think, for new volunteers, but I wanted to share it with you as well. And it's on our website under our resources page. Where's my mouse? So we have a resources page here. It has all of our methods fact sheets, but it also, I put here the stream monitoring calendar. You can download it. It's interactive. You can check the boxes if you've completed the parameters, and there's some other reminders like sending in data sheets at the end of the season. So kind of just like a easy, nifty resource that we're sharing with all new volunteers. The other resources we have on our website, I think this is one of the last updates I have before I jump into the methods. We have our monthly e-newsletter, which if you're not already signed up, you can do that on our website. Every month I send out you know, a newsletter that includes blog stories or learning opportunities, announcements about the program and reminders. So I definitely encourage you to read that every month or at least skim it. I know everyone's busy and find things most relevant to you. Also on our website, you can find the data sheets and print them for yourself for the year. You can print the fact sheets for yourself if you'd like about each of the monitoring methods that WAVE volunteers cover. And I already mentioned the data dashboard. Okay, so I'm going to pause for just a moment and see if anyone has any questions before I jump into our refresher of the methods. And I'm going to get myself a drink of water. Okay, well, if you think of anything, feel free to drop it in the chat. So let's go through the monthly visit to our stream site and what we recommend volunteers do. Okay, so the first thing you do when you arrive at your stream site is, you know, most of you will probably already have a spot you go back to monitor to every single month. But typically volunteers, you know, when they first arrive, they'll mark with a flag, hey, or wrap a piece of flagging tape around a tree that says, this is where I'm going to collect my data every month. Because the WAVE stream stations and swims are pretty long, actually. And so we're just monitoring one spot in that station, and we want to come back to that. We suggest choosing a spot where the water is flowing freely and normally, rather than a spot where the water is pooling, like if there's an obstruction. We definitely have volunteers who encounter down trees after a storm event at their site and they have to move up or downstream, and that is completely fine. As I said, the WAVE stations are actually fairly long, and WAVE volunteers are monitoring a specific spot at that station. So when you come back the first time in the year, just make sure your site is still accessible and where the water is flowing normally, and mark it with a flag. And then we ask that you completely fill out your data sheet when you arrive. You can do this ahead of time, you know, at home with all the details about your station. And it's really important that you do write out what your official DNR station number is, your official DNR station name, the date, time, and the names of the people there. because when we're doing our data quality checks over the winter, or if we're searching for a lost data sheet that you've sent in, we'll only be able to find that and do these checks if that station info is completely filled out. We also, then you want to fill out the weather before you start collecting data. So let me see, what do I have next? Okay, jump right in. So for weather, it's important because the weather is on the current day and multiple days prior is going to affect what's happening in that stream. So we have the categories for the weather for today: sunny, partly sunny, cloudy, etc. We have the weather over the past 2 days, which you can describe. So particularly if there's been a temperature swing, and if it's been raining, you're going to see some differences. Or if it's a really hot day and dry weather the past few days, you're going to notice maybe the water temperature is warming up and the stream flow is lessening a little bit. We also have the sampling date on the right-hand side, primary, safety, or other. If it's primary, that means that you're going out on that Saturday, the 13th that you chose, and there's nothing interfering with your ability to do that. If it's the safety date, it means you're going out, you know, maybe on the 16th because there was a storm event that made the stream unsafe to enter on the 13th. And if you choose other, you know, maybe you're on vacation and you couldn't make it out exactly on the date you planned, so you can tell us that. Then we have the current stream condition. So we might have normal, which, you know, if you've never been to the stream before, you might not really know. And so as you start to visit the stream site over the course of the season and year to year, you'll get a feel for, oh yeah, this is a pretty normal condition for my stream. You can also look at the stream banks where kind of the watermarks are and gauge whether it seems to be lower flow or higher flow. If the stream dries up, you know, in July or August, then you would choose dry. So this is just indicating for biologists and decision makers about that stream, watershed planners, kind of what the stream is doing over the course of the season. Observations are really useful too, and I always see volunteers filling this out well, noting any changes like algae growth. I've noticed oily sheens in my impaired stream from a lot of runoff from urban areas. If you want to note any aquatic life you saw or any, you know, it can be positive or negative. So we don't just need to highlight the negatives. If you know, see brook trout, or if it seems, if you notice a lot of native plants, you can highlight that here too. Okay, so the first thing that we recommend folks measure is temperature, the easy one. So to measure temperature, you go to that flag, that sampling point that you marked, and you want to enter the stream and kind of get to the middle of the stream. Remember always to walk upstream to your sampling point so you don't disturb the sediment and affect all of your sampling. And to collect temperature, first, when you're in the stream, hold the thermometer at eye level and collect in Celsius the air temperature. So do that before measuring water temperature, because it takes the thermometer a while to adjust after you've dipped it in a stream. Then once you've written down air temperature in Celsius, you're going to hold that thermometer underwater until the reading stabilizes. You can check it a few times. If it still seems like it's dropping, for example, put it in the stream again. It can take a few minutes for it to stabilize, or maybe it'll take less than that. So the most important thing is that it has stabilized. And then you're going to record the water temperature in Celsius. So here's just an example of me holding it at eye level. Some folks have suggested, you know, you can fill a clear plastic cup from the stream with water after you've been holding the thermometer in the water for the temperature stabilize, and then hold it up to eye level. But don't take a sample of water from the stream, go to shore, and then put the thermometer in the cup, because it's going to be a different reading than the water temperature in the stream if you're holding the thermometer in the stream the whole time. It's just the volume of water that's in the stream versus the volume of water in a little cup. You're going to see temperature differences. And then we go to transparency. So similar method as before, you're going to go to your sampling flag. You want to walk upstream to that sampling point so you don't kick up sediment. That's particularly important for things like transparency and dissolved oxygen. And on your data sheet, there's a place to circle the length of the tube, and almost everyone should be using a 120 centimeter long tube. I think in the past, some folks had a 60 centimeter long tube, but those are not as common. So go upstream to about the center where the water is flowing normally, face upstream and fill the tube from about the middle of the water column. And if the water is particularly shallow, the vast majority of volunteers are monitoring streams. They're less than a foot deep. So if the water is shallow, one trick is when you're holding it underwater, you can put your hand over the top and then lift it up, and that'll keep the water into the tube. And then the next step is to carry the tube to the shore to read the reading. So you're standing on the shore. You want to make sure that you block any light that would be coming through and filtering through the water in the tube. So stand with your back to the sun. Remember, if you're wearing sunglasses, to remove your sunglasses. If you're wearing glasses for eyesight, you can definitely keep those on unless they automatically, adjust to the light outside. Then you're going to have to use a different way to see. You want to release the water in the tube until you can just see the black and white contrast of the sucky disc at the bottom of the tube. So just when you can just make out that contrast, that's when you're going to stop letting water out of the tube and you're going to record the reading. So in the picture on the right, it looks like it's at about 61.4 centimeters. So then you're going to go into your stream, dump the water out, and repeat the process because we want a few samples that we can take the average of. So to take the average, you add your 2 samples and you divide by 2. All right. Again, if you have any questions, feel free to drop them in the chat, or if you'd like to ask your question verbally, let us know in the chat and we'll pause and give you a chance to ask your question. So the next thing we do is dissolved oxygen. And I'm going to talk about measuring dissolved oxygen with the Hawk kits. So before you even go out, make sure that your chemicals are not expired. Particularly look at your starch solution because it's the one that can go bad very easily. It really can't stand hot or freezing temperature swings. So if your starch solution bottle is cloudy or there's a lot of particulate matter at the bottom, it might not work very well. It might not dye your sample blue. And so it's good to check that ahead of time. Let us know or let your WAV coordinator know if you need a replacement. And make sure that you have enough reagents that will last you for 6 sampling methods. So 6 times out on the stream this year. Okay, so when you are monitoring for dissolved oxygen, make sure you note the method you're using because we have volunteers using meters. Some are using an older Lamont method, not older, but older for WAV, Lamont method. So if you're using the Hawk kits, circle Hawk kit on your data sheet. And once again, you're going to go to your sampling flag. You're going to walk upstream to it, to your sampling site to collect your dissolved oxygen sample, your bottle sample. So face upstream and you're going to fill the bottle from the middle of the water column or so. You don't want to get a bunch of sediment in it from the stream bottom, and you don't want to only collect the surface water. So you're going to kind of move your bottle around underwater so it fills up nicely. And then if you hold it upright underwater, and twist it around a little, allow those air bubbles to escape that you introduced when you put the bottle from the air, underwater. So that's a hot trick. And then you want to put the cap on underwater so you don't have to deal with air bubbles until later. So once you have lifted your capped sample bottle out of the stream, before you go to shore, look at it and make sure there are no air bubbles in the sample. And if you're all good, then you can bring the sample to the stream side to process it. It's really important to remove all the air bubbles because we are measuring the amount of oxygen dissolved in the stream at that time. We don't want to also measure the amount of oxygen in the air, which is what those air bubbles would be representing. So we don't want to delay our chemistry because the oxygen in the water is constantly being exchanged with the oxygen in the air. It's trying to equilibrate. So we want to fix that oxygen that's present in the water as soon as we get to shore. So safety first, put on any safety glasses you have if you want to wear gloves to protect your hands from the chemicals in the which are a little bit acidic in the packets. You can wear gloves as well. And the first step is to add 1 packet of the reagent 1 and 1 packet of reagent 2 to your sample, which I'm showing here, reagent 1 on the left, reagent 2 on the right. And then you're going to put the cap back on, check that no air bubbles have been introduced. And once you know you don't have any air bubbles, you can start shaking that sample for 2 minutes. So you want to, make sure you're mixing super well, tilt your wrist from side to side, and make sure those chemicals are mixing thoroughly because those chemicals are going to be attaching themselves and interacting with the oxygen molecules dissolved in the water. We want all of the oxygen to be represented. After 2 minutes, you're going to put your sample down and you're going to let what we call the flock, the kind of orange brown stuff in the sample, settle to the bottom. And once it has settled, basically once it's clear on top and the flock is on the bottom, then it's ready to shake again for 2 minutes. So we shake a second time for 2 minutes again, just to make sure that chemistry has had enough time to happen and that we're capturing, all the oxygen molecules in the sample. Okay, so next step is to add the third reagent. So we're gonna open that very frustratingly tough plastic capsule and get it into the sample. So pour that in, put the cap on, and shake for 2 more minutes. This is where your sample is going to be dyed that iodine orange color. And once you've shaken that for 2 minutes, you are ready to go. Your sample is now stable. You could take it home with you if you'd like, although I recommend just finishing it on the stream side. And so we move on to the titration phase of measuring for dissolved oxygen. So the next step, we're going to use 2 of those narrow cylindrical tubes, and you actually circle that you use 2 tubes on your data sheet. And so we fill 2 of these cylindrical tubes to the brim, and we pour each one into our square sample bottle. So using 2 tubes allows us to be accurate to the nearest 0.5 milligrams per liter of dissolved oxygen rather than 1 milligrams per liter of dissolved oxygen. So once you have those 2 tubes in your square mixing bottle, then we can titrate. So this is the process of adding our sodium thiosulfate solution drop by drop to our sample to count the amount of dissolved oxygen in our sample. So you're going to take your sodium thiosulfate solution and the dropper, fill it up, hold it straight above your square mixing bottle, and count every single drop that you drop into the bottle and swirl to mix the solution after each drop. You can pause after the solution has turned a pale yellow or after about 10 drops if it, hasn't really been changing much. It really depends how much oxygen is in your sample. But you want to pause once it turns pale yellow for sure, and add your starch solution. So you add 3 to 4 drops of the starch solution, which interacts with the iodine to dye it a dark blue. And the only point of this is to make it visually easier to see when your sample turns from yellow or now blue to clear. And that's when the titration process is done. So that's why we use the starch solution. It's not necessary to test for dissolved oxygen, but it makes it a whole lot easier to see that change happen, so we can be more accurate with counting dissolved oxygen. So we add those 3 to 4 drops, and now on the right-hand side of the picture, you'll see that our square mixing bottle has been turned like this deep inky blue color. So once, so then we continue counting the number of sodium thiosulfate drops. So let's say I, did 10 drops of sodium thiosulfate. I paused to put in a few drops of the starch solution. Now I'm going to start counting, okay, this is my 11th sodium sulfate drop, and I'm going to swirl. This is my 12th, and so on. And as soon as that bottle turns clear, you stop. Sometimes the chemical reaction can happen instantly, which is always a pretty cool effect. So that's why you want to make sure, especially near the end, that you're mixing it really well so that chemical reaction can happen. Once it's clear, write down the number of drops on your data sheet, and then to count milligrams per liter of dissolved oxygen, you take your number of drops and you divide that by 2 tubes. And then we need to also write down the percent dissolved oxygen saturation. So dissolved oxygen saturation is, it's based on the temperature of the stream, the amount of oxygen that can be dissolved into the stream. If it's 100%, that means that the stream is kind of in balance based on its temperature, holding the amount of dissolved oxygen that it can hold in a stabilized situation. But it can also be above 100% or below 100% if that stream is not holding as much oxygen as it could, given the temperature of the stream. So we collected our water temperature in Celsius earlier, and this tool is on the back of your hot kit instruction card. You basically draw a straight line using a straight edge, like a piece of paper, between the water temperature you collected and the dissolved oxygen in milligrams per liter you just collected. And where it crosses that center measuring line is your percent oxygen saturation. All right. So I don't see any questions yet. Feel free to drop them if you have them. The last thing I'm going to talk about is streamflow before I hand it off to Emily. Streamflow, I know, is a bit more complicated, and so feel free to ask any clarification questions. I know some of our nutrient sample monitoring volunteers also do streamflow, so it's a really useful one to have if you're planning to do nutrient sampling in the future as well. Okay. The first thing I want to note is that I know there's some volunteers out there whose streams may dry up at some point. So I want to make this distinction. If you have an intermittent stream, these are streams that are usually wet. Basically, they usually have water flowing, but there may be some months that have low flow or no flow. So what do you do if you arrive at your site and your stream has dried up for that month? We still want you to submit a fieldwork event and note that the stream had low flow or no flow and that you couldn't collect data on it. This is going to indicate for biologists what is happening seasonally with that stream. And that way we know that the reason there's no data is because there was low flow. It's not because, you were sick or on vacation or something like that. An ephemeral stream is one that is usually dry. And these are not streams volunteers should be monitoring. So if most months of the year the stream has no flow or low flow, You know, the DNR says it's not worth it for us to be monitoring that stream. And so it's better to find another stream site. So the method we use to do stream flow is the float method. This is a really common method used by a lot of people across the US. And I always like to share the equation that we're using for those of you who find it easier to understand, you know, the different components of measuring stream flow discharge. So the equation is we are going to get stream flow discharge in cubic feet per second. So the units are important. We do that by first measuring the area of the stream. So, and then multiplying that by the velocity of the water in the stream. So part one, which I'm going to talk about, is measuring a cross-sectional area of the stream. And what we do is we collect data on the width of the stream at that spot. We're going to cut the stream like a cake and measure the width. And then we're going to multiply that by an average depth of the stream. So that's why we take all those depth measurements across the stream to calculate an average depth. And those combined give us the area. Then we want to know how much water is flowing through that area. So that's where we're measuring velocity, which is the distance we're measuring is 20 feet. All of us are going to measure 20 feet of stream length, and how much time in seconds it takes for a tennis ball to float that 20 feet. So those are the two components that we are measuring for stream flow. And I see a question in the chat from Ellen. We have been filling the DO collection bottle and then dumping it 3 times before taking the sample. Is this no longer considered necessary? I think that's totally fine. You know, I guess I haven't recommended it in the past, but it is good to make sure, you know, that the bottle is being rinsed out so that any chemical residue in there is gone. So I would encourage you to keep doing that. Absolutely. Okay. So back to stream flow. Just want to emphasize again, the units we're using, which are really important. We are not measuring in inches. We are measuring in decimal feet or tenths of feet. So the tape measuring reel that we give to volunteers has decimal feet in it. This basically breaks up a foot into 10 equal sections, 0.1 through 0.9. And so the reason we do this is avoid having to convert inches to feet, because these are actually 2 different units of measurement. So in the picture here, we have, let's see, it looks like it's less, I haven't looked at this picture in a little while, less than a foot. So you can kind of see the 1 foot mark on the right-hand side. The top measuring tape is in inches. So you can see the foot is broken up into 12 parts. And the bottom one is broken up into 10 parts. Sorry, I'm losing my voice. So we want to, definitely losing my voice today. Been talking a lot lately. 8 3/8 inches is equal to 0.7 feet. And Emily might have to take over in a minute if I totally lose my voice today. Okay. So the first thing we want to measure is the cross-sectional area of the stream. This is part 1. So where our marking flag is where we want to cut the stream like a cake and measure the width. You can use stakes to attach your tape measure taut over the stream, or if you have enough people, they can hold the tape measure over the stream. Just make sure it's pulled taut. And we want to measure the width from wetted edge to wetted edge, where the water ends on each edge. So then you're going to record that width in decimal feet or tenths of feet. Then we're going to record the average depth. So starting at that wetted edge, you want to go in 1 foot and measure the depth of the water. Then you're going to go in another foot and measure the depth of the water. And so you're going to write these down. And then when you get to the other side of the stream, as soon as your net hits dry land, you're going to stop taking depth measurements. So your last depth measurement should still be in the water. And this is one of the biggest mistakes we see, which we emphasize every year. We don't want to see any trailing zeros on stream flow. And what we mean by that is when we're seeing volunteers list their depths, we don't want the last depth to be 0, because that means you got to the other bank and you hit dry land and you recorded a 0. And also, we don't want you to be filling in zeros for all the 20 points, because this is going to mess with your calculation of average depth. What that would be signaling is that you actually have 20 depth points rather than 8 depth points, and it's going to really mess with your average depth. So here's an example of my data sheet. I wrote down that my stream width is 11.5 feet wide. I took, therefore, a depth measurement every 1 foot. And so the first point on there, you'll notice, is 0. That's representing both edges of the stream, both banks of the stream. And then I went in 1 foot, and my last depth measurement there is 0.2. That was my last measurement in the water. So I have 11 measurement points then. And that's all I record on my data sheet. I don't fill in the rest with zeros. So what if my wadeable stream is more than 20 feet wide? In that case, you're going to take the width of your stream and you're going to divide it by the 20 depth points that you have available. So example, which on the right-hand picture there, that stream is probably more than 20 feet wide. Let's say it's 23.5 feet wide. I'm going to take that number and divide it by 20 points. And then I'm going to end up with having to take a depth measurement every 1.175 feet, which is super awkward. So to make it easy on yourself, round up to the nearest 1.5 feet or 1.25 feet. That'll make it a lot easier. And then okay, my first depth measurement is at 1.5 feet. My second depth measurement is at 3 feet. My third depth measurement is at 4.5 feet. And then you won't get confused along the way. So you'll end up with 16 depth measurements, 16 points you're collecting depth at. The most important thing is that you're collecting depth at equal intervals, so that you're not underrepresenting different parts of the stream and throwing off your average depth for the stream. So what if my stream is really narrow, like in the picture here, which is only a few feet across? I recommend measuring every 1/2 foot, as long as the intervals are equally spaced. So if I have a 5.4 foot wide stream and I measure every 1/2 foot, then I'm going to end up with 10 depth measurements. That's going to give me a much more accurate average than if I only have a few depth measurements. And then the second part to stream flow is velocity. So we have finished part 1. We have our cross-sectional area. The first half of the equation is done. And now we're moving on to measuring the velocity of the stream. So we have our center point flag. We're also going to add a flag 10 feet on either side of that center point flag. And that is going to be our 20 feet. Now we need to prepare to measure the velocity between that 20 feet of distance. So take your tennis ball, fill it halfway with water so that the tennis ball sits in the stream a little bit, kind of floats deeper in the water column. That is so that the wind won't push the tennis ball. So you're really measuring the flow of the water and not getting interference from other factors. And use a stopwatch, just time how long it takes for that tennis ball to cross the first flag and reach the final flag. Make sure you allow the tennis ball to kind of get momentum as well, because it takes a few seconds for it to match the flow of the stream. And you want to repeat this 4 times to get an average velocity. So you want to start the ball, on the left-hand side of the stream, in the center, and then on the right-hand side. Vary it up, because as we know, streams are very variable and they may have slightly different flow on different parts of the stream. Suzanne says, I've never heard of filling the ball halfway with water. Not sure if there's a hole. Should I start doing it after 4 years? If there's no hole, should I make one? Yes, we definitely recommend you can take a knife and slice just a slit, maybe like a couple inches wide in the ball. I usually mark it with a marker so I can find it each time. And that's all you need to do to start filling it with water. And it could be that your data is just fine. It's really to help make sure that wind isn't interfering, you know, and that water, that tennis ball is representing that surface water flow. Then finally, the last piece is the velocity correction factor. So we have either rough or smooth bottom streams. And the reason this is important, and it's important you assess that, is because the tennis ball is only floating on the top of the stream on the surface. And depending on the roughness or smoothness of the stream bottom, the water may be flowing slower on the stream bottom compared to the surface. And so this correction factor, you know, corrects for that difference. So a rough bottom stream is one with a lot of plant life on the bottom, creating friction against the water, or maybe a lot of rocks on the bottom, creating friction. And a smooth bottom stream might be one that's, you know, mostly silty, sandy, smooth, or maybe really flat bedrock and the water's just flowing quickly over it. Just a few more points to make. One is I just want to make sure you're aware that with the float method, because we're doing a lot of averaging, the float method over measures stream flow by 24%. So there's been research been done on this, and it's pretty consistent with this. So if you have a stream flow gauge very close to your site, you can compare what that stream flow gauge is reading with your float method, but make sure you're correcting for that 24% difference. So when you're entering data into SWIMS, you don't have to do anything because SWIMS automatically corrects for this difference by multiplying your stream flow reading by 0.76. Essentially, it reduces it by 24%. And if you want to practice the math by hand, you can do so using a worksheet that is available on our website under the resources page. It's fun to do at least once. Okay, I think I'm going to hand it off to Emily at this point. If there are any questions, I will chime in afterward.
All right, we are going to go, oh, let's see. We have a question in the chat here real quick, Katie.
What if your stream is usually 20 feet, but the water is low this month? Does this alter your wetted edge measurement? Yes, you can, as your stream becomes wider or narrower, you're going to want to adapt every measurement you're taking. You're going to want to take a new width measurement. And depending on that width, you know, you can just, depends how narrow it gets, right? But I would say you want to try to get at least 10 depth measurements across the stream. And if it's, you know, up to 20 is necessary, you know, as your stream gets wider. Do you measure width based on water flow? Or do you keep your, yeah, you always measure the width of the stream based on its condition that day you go out. You explained why SWIMS math doesn't match my simple math, the 24% correction. Great, yes, that's a good point. Yeah, I'm not sure what you end up seeing, but that would be why. Okay, go ahead, Emily.
All right, yeah, if anyone has any more questions, just pop them in the chat and we will answer them as we go. Okay, so we're going to talk about biotic index next. And with that, I like to think that it's everyone's favorite part of monitoring. So who doesn't like searching for bugs in the water? So as a reminder, you don't need to do this every single time you monitor, just twice a year. So once in the spring and once in the fall. So the goal with your biotic index survey is to sample a wide variety of habitats for those bugs. So spread out across your sample site. We really recommend searching for those macroinvertebrates in about a 300-foot stream section. And you really want to sample a diverse range of habitats because different bugs prefer to live in different places of the stream. So when you're sampling for those macroinvertebrates, the highest area of diversity for bugs are riffles, followed by undercut banks, snag areas and tree roots, and then leaf packs. So choose 3 of those locations to sample from, choosing the most diverse areas you can find. So to sample a riffle, one sample actually has 2 steps. You sample below and above the riffle. So start downstream of that riffle. You just put your net against the bottom of the stream and start kicking in front of it in order to dislodge those bugs. And we like to say, kick it like you mean it, because you're trying to dislodge those bugs from the sediment and the rocks below it. So after you've kicked about 20 times, have your partner hold the net while you pick up rocks and rub those together in front of the net. And then repeat that process on the upstream side of the riffle. And then dump your net into your large tray. To sample from an undercut bank, just scoop the bank from the bottom to the top about 20 times and then dump your net. To sample from snag areas and roots, just run your net along about a 3 by 3 foot area, scooping along the surfaces. And then for leaf packs, hold the net downstream and scoop some leaf materials into the net, and then bring that leaf pack back to the tray and slowly sift through it for the bugs. So again, choose 3 of those diverse habitat types to sample from. Next slide, please, Katie. Okay, and then once you have all your samples collected and dumped into your big tray that has, make sure you put a little water in it. Go ahead and let that tray sit for a couple minutes, and that will allow the sediment to settle and the bugs will start to emerge from hiding. That's definitely especially important if you picked up a lot of sediment or if you have a lot of leaves in your sample. And then you're going to use your ice cube tray to sort insects by similarities. Next, you're going to use your key to life in the river to identify the bugs you found. And on your data sheet, circle each bug you found. And you're just going to tally the number of bugs circled within each sensitivity group. And that's what you enter into SWIMS when you're doing your data entry. So pretty straightforward with the biotic index there. Go ahead, Katie. All right, and then for AIS monitoring, aquatic invasive species monitoring, just remember that as a part of baseline monitoring, we ask that volunteers keep an eye out for 4 species while they're out doing the routine monitoring. There isn't a specific protocol for this. We just ask that folks keep an eye out. And you're most likely to see these guys when you're out doing a biotic index survey, but it's good to check for them each time you're out too. And the 4 species that we ask people to look out for are New Zealand mud snails, faucet snails, rusty crayfish, and then Asian clams, also referred to as freshwater golden clams. So those 4 species were chosen by DNR as especially concerning in streams. And anything that you find that is suspect, I recommend taking a sample. And since snails and clams are tough to identify, just put it in a container with a little bit of water and then put it in your fridge or freezer so they don't get stinky. And then you can report that to your local DNR AIS coordinator, which is pretty easily found. You can just Google DNR AIS contacts. It's also on the website on the new 2022 data sheets, or you can always contact us at WAV and we can put you in touch with the correct person. Next slide, please. If invasive species monitoring is something that is interesting to you, you might be interested in this new opportunity that we have for aquatic invasive species monitoring. So new this year, WAVE has absorbed the program called Project RED, which stands for Project Riverine Early Detectors. It's an invasive species monitoring program for volunteers to search for invasive species on moving waters, so any river or stream site. So if you're interested in aquatic invasive species monitoring at your stream site or on any stream in Wisconsin, this is the program for you. As a part of Project RED, volunteers, again, they can monitor on any river or stream, either in or out of the water, and they can look for any of 23 different species. So we have a lot of training materials available. So if you're interested in becoming a Project RED volunteer, check out our website. I listed that for you below here. It's just wateractionvolunteers.org/Project RED. There's a monitoring manual to get you started on how to monitor for invasive species. And then we also have trainings available for you to attend and learn how to identify those different invasive species. So all those trainings are on our website under the events tab, and you can find a training in your area to attend, or just check out that manual and it gives you all of the information that you need to get started. Next slide, please. So that about wraps up our the methods for the baseline monitoring. And I just want to give you a couple updates about SWIMS and data entry. So next slide, please, Katie. So the SWIMS interface has undergone a redesign. So the functionality will remain the same. Okay, so if you're familiar with the prior version, it's the same functionality. It's just that the layout has been updated to a more modern look and feel. So the database where all of our water quality data, pictures, documents, etc., have been stored, that has not changed. So the interface will look a little different, but the information found within it has not changed. So all WAVE volunteers entering stream monitoring data into the DNR's SWIMS database will be affected by this SWIMS update. And Katie and I have been helping to test the new SWIMS for several months now. I can promise that this new version is much more intuitive to use. It'll be a slight change in terms of learning the new interface, but once you get used to it, it's really straightforward. So to get to that new interface, go ahead and visit our website under the data tab, and then you click submit data. There's a big button here that will link you to the new website. So you can click that, bookmark it, and have it for the future when you go to enter your data. And we've created a variety of resources to guide you through that new SWIMS that we detail exactly how to enter your data step by step. And those will all be going up on our website as well. We just had a training the other day about entering data, and we recorded that, and we will be disseminating that recording out to everyone. Next slide, please, Katie. And as a reminder, with your SWIMS questions, go ahead and come directly to us to ask your initial questions. There's no need to go directly to the DNR SWIMS team. A lot of times we can answer those a little bit more quickly than DNR will be able to. So I'm going to be fielding those questions ahead of DNR just to take off some of their workload. So you can come to me for anything SWIMS related, especially things like creating new monitoring stations and assigning a volunteer with a WAMS ID to a monitoring project and stations and SWIMS. So, or if you're just having a hard time entering your data, let us know. We'll walk you through it and we'll help you out. So you can go ahead and use the general WAVE email account for SWIMS questions. It's just wave@extension.wisc.edu. And if we can't help you, we know the right people to get in touch with who can. So don't worry, you're going to have a ton of SWIMS support. So coming up, we want to give you a couple updates on some fun and exciting events that are coming up that you might be interested in. I just wanted to make sure you're all aware of the upcoming Lakes and Rivers Convention. It's a really awesome event. There are workshops and sessions for pretty much anything you can think of that is water related. There are almost 600 people that are attending this year. So water lovers of all kind are coming to this event. So it's a great networking opportunity. It's a really popular event and we would love to see you there and meet you. Katie and I will be having a table there and we'll be doing all kinds of moderating sessions, giving talks. We'll be all over that conference and we'd love to meet you. So if you're going to be there, make sure you find us and stop by and introduce yourself. Go ahead and visit wisconsinwaterweek.org to see the agenda and list of workshops available, and we hope to see you there. And next slide. Yep. So if you have any questions, again, we can take them in the chat right now. We have a couple minutes. Well, it looks like now we have 1 minute to answer questions, but Katie and I will stay on a little bit after this and field questions. You're also always welcome to email us, give us a call, visit our website and sign up for our newsletter. Let us know your questions, let us know your successes. We always love to see pictures of you guys out doing fun things. And so get in touch with us if you need anything, or if you just want to make a comment about things that are going well or things you need help with. So thank you again for attending the training today, and we will take any questions that you have.
Did I go ahead and ask a question verbally rather than through chat?
Yeah, go for it.
Yeah, this is Ellen Brooks over in the southwest part of the state. The question about what date you use. When we first started many years ago, we did the 13th of the month or the 15th of the month or whatever. Since then, probably for at least the last decade, the Valley Stewardship Network that is our coordinator, they have said, no, take the third Wednesday or the second Monday or whatever, not the same date of the month, but rather the same day within that month. And I asked about that, and my recollection is that they said that's the way the DNR does it, so that's the way we want you to do it. But now you're telling me go back to the 13th of April or whatever. So
Yeah,
whenever.
that's a great clarifying question. So I think the idea, you can really do it either way. The idea is to really space out your monitoring evenly throughout the season. And however you want to make that work is totally fine. We also have some people who do it, some coordinators, for example, who are kind of working with volunteers to collect data for a watershed, like planning or management effort. They may ask, if you can do it earlier in the month so that all the volunteer data is coming in at the same time and they can make better comparisons, same kind of time of the month, like early May to early October. That can be helpful. So that might be why they're asking for that kind of coordination between, Valley Stewardship Network volunteers. But the idea is to space it out evenly.
Right. Okay. That's good to know. The project, the new project that, well, it's not that new, but the newer project that we're working on is called the Wallace Project, and it's in the Tainter watershed. It's a special project within the Tainter Creek watershed. And so I think that's part of the reason that, and they do want everybody there's, I don't know, like 5 or 6 of us anyway that are taking.
Gotcha. Yeah, I'm guessing they're trying to coordinate their monitoring samples.
Okay. Okay,
Yeah.
good. Thank you. Appreciate
Yep.
that.
Great question. And I'm going to go ahead and stop the recording, but if anyone else wants to ask a question, feel free to jump in.